Hey everyone, welcome back. So today we will discuss machine account password process. So in this video, we will learn how Active Directory computer accounts silently rotate their own password. Did you guys know every computer in Active Directory actually has its own password? And that's the most interesting part. It changes automatically without any administrator clicking a single button. So today let's uncover exactly how that entire process works behind the scene. Okay. So when most people hear password, they immediately think about user account. You might also think about the user account, but computer have password too. Every domain joined Windows machine gets its own computer account in Active Directory, along with a secret password. That password is what allows the machine to prove its identity every time it's communicate with a domain controller. Without it, the secure channel between the computer and the Active Directory simply would not exist. So that's the importance of computer account passwords. Okay, so it's authenticate using this password to the Active Directory. Okay, now let's understand who is the password then. Now here's something that surprised a lot of administrators. Many people believe the domain controller tells computer when to change their passwords, but that's actually a myth. The domain controller never initiates the process. It's the client computer itself that decides its time to rotate their password. The Netlogon services running on the workstations start everything while the domain controller simply validate the request and store the new password. Okay. So in other words, the client takes the initiative and Active Directory simply respond. So that's how the machine's account password changes in the background. Okay. Now let's understand when does this happen? By default, every 30 days. This behavior has been built in into Windows since Windows 2000. Microsoft chooses intervals to reduce the risk of long-term credential compromise while avoiding unnecessary network traffic. And if your organization wants a different schedule, you can easily configure it through group policy using the settings called domain member maximum machines account password is. So we can change the default time of default 30 days time. Okay, we can simply make it in 90 days or 180 days as per our requirement. Okay, now let's understand the workstations how like validate if the password has been expired or not. How does Windows even know when those 30 days are over, right? Well, it does not constantly check the clock. Instead, the Netlogon services runs a small background worker called the scan thread. Every 15 minutes, it wake up, perform a quick check, and ask a very simple questions. Is my password older than the configured maximum age? If the answer is no, it goes back to sleep. If the answer is yes, that's when the password change process begins. Okay. Now let's understand the full password change flow. Let's follow the entire process from beginning to end. First, the workstations verifies that the password has expired. Next, it establishes a secure channel with a domain controller. Then, and this is important, the computer generates a completely new random password locally. That new password is securely sent to Active Directory, where the domain controller updates the computer account. Okay. But Windows adds one extra layer of protections. Instead of immediately forgetting the previous password, it temporarily keeps both the old and the new password locally. That backup can save the secure channel if replications delays or communications issues occur. Okay, so that's the complete password change flow happens in the background. Okay. Now let's understand, where is the password stored? Now you might be wondering, right? Where are these passwords actually stored? On the workstation itself, Windows stores them inside a local security authority or LSA secret. You will find values like current value, which represent the current password, and old value for the previous one, and informations about when the password was last changed. Inside Active Directory, things look a little different. The computer object attribute include unicodePwd, password history, and one attribute you have probably seen before, pwdLastSet. That last attribute tell us exactly when the machine's account password was updated. Okay, so that's how the local registry and Active Directory kept the current value password and the previous value password. Okay, now let's understand why decoding password large set with NLT test. Okay. Now, if you have ever looked at password last set, pwd last set, you have probably noticed it does not exactly look human friendly. It's just a huge decimal number, right? Fortunately, decoding it's a very pretty simple. Convert the value into hexadecimal, split it into two parts, and pass both values into the nltest/time command. Windows then convert that raw time stamp into an actual readable date and time, making it much easier to verify exactly when the password was changed. Okay. Now let's understand the two common edge cases. Two situations every admin should know. Before we finish, let's look at two situations that often confuse administrator. First, imagine a laptop that's been sitting offline for several months without connecting to the corporate network or VPN. Since it cannot reach a domain controller, it simply cannot rotate its machine account password. And that's completely normal. The second scenario is a system restore. If Windows is restored to a point before a successful password rotations, the local password and the one stored in Active Directory can become different. That's one of the most common resources reason a computer loses its secure channel and start throwing a trust relationship errors. Okay. Okay, so what happens with an RODC? RODC means read only domain controller. One final scenario involves read only domain controller or RODC. Since an RODC is not allowed to write password changes directly into Active Directory, it forwards the request to a writable domain controller. After the writable DC updates the passwords, the new information is replicated back to the RODC. And if the client does not already have a cached secure channel with the RODC, Windows simply contacts a writable domain controller directly. So that's how the RODC play an important role in the Active Directory. Okay. So let's quickly bring everything together. The client computer, not Active Directory, start the password rotation process. By default, that happens every 30 days with Netlogon checking every 15 minutes. The new password is generated locally, secure, stored in Active Directory, and protected with a temporary local backup. Offline machines simply wait until they reconnect, while RODC forward the password update to a writable domain controller. Okay. Once you understand this workflow, troubleshooting machines account trust issues become much easier because you know exactly what's happening behind the scene. If you found this helpful, give the video a like, subscribe for more Active Directory deep dives, and let me know in the comments what ID topic you'd like me to explain next. Thanks for watching. I'll see you in the next one.